Okay, so we're with year 8, and it's term 1 running the race this time, not winning the race. First lesson we did was on Sankey Diagrams. The big thing here is to know that energy cannot be created or destroyed, it can only be transferred. So those 10 types of energy that we learned in year 7, we're starting to transfer them from one to the other. We looked at these things called Sankey Diagrams, whereby the total energy going in has got to be the total energy coming out. So we got useful energy going across and we got wasted energy coming down. And then this is a mathematical skill where you add them up to see how much is going in, or if you know how much is going in, we're going to calculate the missing value. Lesson 2 is on enzymes. Now it's not on here, but an enzyme is a biological catalyst. We've got this thing called the lock and key theory, where only one type of enzyme will fit a particular substrate. So notice how the shapes match. If the shapes don't match, then it's not going to work, and we call that the lock and key theory. This is the substrate that comes along. The enzyme is going to change it. It's either going to become 2 new products, or you can get 2 reactants to form 1 product there. So enzymes, biological catalysts. Lesson 3 was on digestive enzymes then. Knowing for each of these food groups, so you've got starch, protein and fats, which enzyme works on it. So amylase for starch, protease for protein, lipase for fats. The product of starch is glucose, the product of protein is amino acids, and the product of fats is fatty acid plus your glycerol. Naming salts was lesson 4. It's kind of reference back to the pH scale here. So an acid plus a base gives us a salt plus water. So if we take a base, for example, if I take sodium oxide and I mix that with nitric acid, I'm going to get sodium nitrate. If I got sodium oxide and I mix it with sulfuric acid, I'm going to get sodium sulfate. And if I get sodium oxide and mix it with hydrochloric acid, I'm going to get sodium chloride. Lesson 5 is on ionic formula. You'll be given a formula sheet, so you'll be given some ions. You'll be given their charges, and then we use this method called top, swap and drop. What this allows us to do is, the first step, you'll take away the charge. The second step, you'll actually swap those numbers. So 2 goes to chlorine, 1 comes to magnesium, and then we drop them down. So if this was written on a line, the numbers would be going through that line. Lesson 6 was on word equations. The big thing here is to know the difference between when we use 2 elements and 3 elements. If it's just 2 elements forming to make a compound, we just say it's ides. So anything that it reacts with, so potassium and sulfur, is going to give us potassium sulfide. Whereas if it was potassium, sulfur and oxygen, it would become potassium sulfate. So anything with oxygen in and 2 or more elements with oxygen becomes an 8 at the end. These last 2 lessons then were on distance time graphs. You can see I've got distance in meters going on the y-axis and time on the x. A steady speed is represented by a straight line. From this we could work out the speed. Speed equals distance over time. So in this case it's 20 divided by 2. A straight line just shows that it's doing no distance for the time that's passing. And then a curved line is going to represent either accelerating or decelerating, depending on the way that curve goes. We also talk about how a steady speed, which is represented by a straight line, if you increase the steepness of that line, it means it's going faster. As we can see here, it's covering more distance for less time. And that is term 1 running the race, a recap.